Hello, my dear students. I welcome you all to my Science Nest YouTube channel. Today, I'm going to discuss with you about the material changes. Let's move on to the lesson. There are two types of changes in materials. One is physical changes, the other one is chemical changes. A type of change where the physical properties of matter change is called as physical change. You can see an example. Water turns to water vapor, solid turns to a liquid. These are the physical changes. That means the states have changed. State changes are the physical changes. Solid is turned into liquid, liquid is turned into solids. Likewise, the state changes are known as physical changes because during these processes, no new substances are forming. The same thing is turning into the different state, and they are reversible changes. That means if a solid turns to liquid, when we are heating a solid, a liquid also again can turn into a solid by cooling it. Example he has given here: liquid can cool and bring back to the solid state. That is why I have given as they are reversible changes. Now we will see what are the chemical. We will see a change of materials into another new materials with different properties, and one or more than one new substances are formed is known as chemical changes. This is the chemical change. Is called chemical change. During these changes, the things are changing and new things are forming. That is the way of the chemical changes. Example has given iron and sulfur are combining together to form iron sulfide. Iron sulfide is forming. Another thing, we can show what happens during a chemical reaction using a word equation. This example is showing a word equation. We are showing all the things happening in the reaction by using the words. The substances at the start of the reaction are the reactants, and the new substances that are formed are the products. Then, this reaction, iron and sulfur are reactants, and the iron sulfide is the product. And you can see the reactants are changing or transforming into products during the chemical reactions. In some chemical reactions, a substance breaks apart to produce two or more new substances. As in this example, you can see H2O is forming in turning into H2 and O2. It is a chemical reaction. In this, you can see one oxygen and two hydrogens in this water molecule, and while the reaction, two hydrogens are forming together, combining together, and two oxygens have combined together. That is how they are rearranging. That means the particles are rearranging. Atoms are rearranging with another atoms to form a new thing. That is the way of the chemical reactions. Now you can understand during the physical reactions, no any new things are forming, but during the chemical reactions, new substances are forming. Next topic, chemical reactions in living organisms. One thing happen in plants when they grow and when leaves decay. It also a type of chemical reaction in living organisms. And next one happen inside the body to keep us alive. Inside our body there are so many chemical reactions are happening. One example is reaction to digest food. Food digestion is one type of chemical reaction happening inside our bodies. Burning, it is a type of chemical reaction, very fast reaction, and the substance that is burned combines with oxygen. Burning means the substances are combining with oxygen. Here example has given magnesium is combining with oxygen when it is burning and it is forming magnesium oxide. Magnesium oxide is a white color powder. Let's move to see the uh, reaction happening in that. We'll see we can observe a white color flame here. During the reaction between magnesium and oxygen, then you can see white color flame is producing and also after the burning you can see white color powder is remaining. This flame is known as bright white flame. Next thing, the products formed in the chemical reaction have different properties from the reactants. That is another thing. Always, when the magnesium and oxygen are combining, these two have different properties, and the new substance formed is the magnesium oxide. It has another different type of properties. We'll see the things in this table. Elements or compounds. Then we'll see magnesium is an element, oxygen is an element here. When they are reacting together, the new substance forming is magnesium oxide. It is a compound. Then the magnesium is a solid, oxygen is a gas, but the new thing is a solid. Magnesium is soft, shiny, and it is malleable. Malleable means we can make sheets without breaking by using magnesium. And oxygen is colorless gas and it has no smell. But the white powder producing here is white and powdery. And magnesium can conduct electricity, oxygen cannot do it, and magnesium oxide also cannot do it. Uh, Melting point of magnesium is 651. Oxygen's melting point is very low because it's a gas. It minus 214, and the melting point of magnesium oxide is very high. It is 2800. From this table, you can take the idea the products have very different properties than the reactants that it has made with. Now the reactions with acids. Some metals react with acids, producing hydrogen gas. You can see magnesium is reacting with hydrochloric acid and producing magnesium oxide, chloride and hydrogen gas. We'll see the reaction between these two. You can see when hydrochloric and magnesium is reacting, hydrogen gas bubbles are releasing like this. You can see in the video the hydrogen bubbles are releasing. Now testing for hydrogen. Now we are going to observe whether that releasing gas is hydrogen or not. The test is light a splint and place it on the mouth of the tube containing gas as in the picture. You have to keep a splint on the top of the tube and then keep your finger over the end of the test tube until the last moment because the gas will release if we didn't do that. When the hydrogen pops, it is reacting with oxygen in the air to form water. That means if we can hear a pop sound in this reaction, uh, we can uh, we can tell that this gas is hydrogen gas. Here in the video, you can see hydrogen gas is giving that pop sound. Now, the reaction between carbonates and acids. Carbonates react with acids producing carbon dioxide gas. We'll see one experiment. Calcium carbonate is reacting with hydrochloric acid to produce calcium chloride, water, and carbon dioxide. Now we'll see the testing for carbon dioxide, whether this gas is carbon dioxide or not. When inserting a lighted splint, carbon dioxide makes the splint go out. It is one observation. And another one is carbon dioxide make the colorless lime water milky. You can see lime water. It is the colorless solution. When we are bubbling the carbon dioxide into that, we can see the lime water is turning to milky color. This milky color is because of the calcium chloride producing here. Now, rearranging atoms. When a chemical reaction takes place, no new atoms or elements are formed or lost. The things or the elements or the compounds are not lost, and also new things are not gaining or not attaching to the previous things. The same things are rearranging to form new combinations. As in this reaction, you can see iron and sulfur is there. Those two are combining together to form iron sulfur. In this one, you can see there's magnesium and hydrochloric acid. You can see in magnesium chloride, the magnesium atom and two chlorine atoms in the hydrochloric atom are combining together. Hydrochloric molecules, uh, chlorines in hydrochloric molecules, and the magnesium. They are combining together, and here two oxygen atoms are combining together to form these products. That means the previous things have rearranged to form the new substance. Now the conservation of mass. Total mass of the reactants equal the total mass of the products. In the reactions, the total mass of the reactants equal to the total mass of the product. That means nothing is releasing to the outside, nothing is lost or nothing is creating during a chemical reaction. Nothing is lost or nothing is creating during a chemical reaction. Same things are generating into another new substance. So the mass of the reactants always equal to the mass of the product. But to happen like this, we have to take closed system. That means while we are doing the chemical reaction, we have to close the apparatus that we are going to use to do that experiment. We will see them by using some experiments. This idea is known as the conservation of mass. Now we will see more about that. To do this experiment, these are the steps. Add hydrochloric and calcium carbonate into a flask like this. Measure the mass of it at the beginning and after 10 minutes. These are the masses that you can record. At the beginning, you can say the mass is 250. After 10 minutes, the mass is 207. According to the conservation of mass, these two masses should be equal, but here the second mass has decreased. We'll see the reason for that. The carbon dioxide gas is producing during the reaction between hydrochloric acid and calcium carbonate. And that carbon dioxide is a gas and it is releasing out from the flask because this flask is open. It has not closed, so the carbon dioxide is releasing out. So it appears as if the mass decreases as the reaction continues. That's why the mass has decreased because during the reaction, the produced carbon dioxide has released out. So the number of atoms of the reactants has decreased while the reaction has happened. That it has happened. That is the reason for this decrease of the mass. Now we will see another surprising experiment. Some magnesium is placed in a crucible and the mass of the crucible with magnesium is recorded. Crucible is a type of instrument we use to heat the things in the lab. Then we are putting it into a crucible. It's a pot-like structure, pot-like instrument. Then when we heat, we will see what happens. The lid of the crucible is lifted from time to time. While we are doing the experiment, we are lifting the lid of that crucible. Then when we are lifting, the air in the environment is entering into the crucible. First of all, I'll show you a crucible with a lid. This instrument is called as the crucible. You can see while we are heating it, we have to put some magnesium pieces into this and we have to heat them. While we are heating, we have to open this lid time to time to let the oxygen to enter into the crucible during the heating process. After heating, the mass of the crucible with the content is found again. Then the mass of ashes, now you can see after heating, now there's ash, not the magnesium, because it has burnt. And you can observe that mass of the ashes is more than the mass of magnesium at the start of the reaction. It also do not prove has not proven the conservation of mass because the mass has increased now. We'll see what is the reason for that. Because we have opened the lid time to time, then the atmospheric air has entered into the system. So something has entered. That's why the mass has increased. In the previous example, the gas is released out. That is why the mass is decreased. Here, the mass has increased because oxygen gas is entering to the system when we are opening the lid. Because we know when something is burning, it wants oxygen gas. That's why we have to open the lid here. So the mass is increasing, magnesium oxide mass is increasing because of this entering of oxygen gas. I gave that. There is an increase in mass because oxygen from the air has combined with the magnesium. This was found by Anthony Lavoisier. This is the scientist who found this situation. Now we will see how to detect a chemical reaction. A chemical reaction could be indicated by a color change, gas being produced, a change of temperature, a change in pH, or the formation of a precipitate. These are the things that we can prove that whether there's a chemical reaction has happened or not. If there is a chemical reaction, we can see any of these changes. We can see the color has changed after the reaction. We can see a gas is producing after the reaction. We can see the temperature has changed after the reaction, or the pH has changed. You know, the pH value is a measurement we are using to identify whether a solution is acidic or a basic solution. We know acidic solutions, the pH value is low, that means lower than 7, and the pH value is higher than 7 for the basic solutions. And also sometimes precipitations are forming. Now we will see one example for a color change during a chemical reaction. Copper oxide and sulfuric acids are reacting and forming copper sulfate and water. We will see what is the color change. This is the reaction between the sulfuric acid and copper oxide. You can see a blue color solution is forming. It is not clear. The color is not clear here. So we are going to filter the solution to observe the blue color solution. You know, at the beginning, there's no any color like this, but after the reaction, a blue color copper sulfate has formed. We will see a gas is given off. This is the reaction we have to learn. Magnesium is reacting with hydrochloric acid to form magnesium chloride and hydrogen gas. Then the hydrogen gas is producing here. We will see the video for that also. In this reaction, when the magnesium piece and the hydrochloric acid is reacting together, hydrogen gas is releasing like here. Next thing, heat is produced. When the reaction between potassium and water, the products are potassium hydroxide and hydrogen gas. Other than that, heat is producing. When you touch the surface of the container of the products, you can feel it is very hot. That means heat has produced. And from that we can tell that a chemical reaction has happened during this. A change in pH If you add potassium to water, like in the previous reaction, that contain universal indicator, the indicators are using with to observe whether something is a acidic thing or a basic thing. So you see the indicator change color from green to purple. This shows that the solution has become alkaline. Alkaline means basic. From the universal indicator, we can see the solution has turned into alkaline solution. That means from this you have to take the idea that while a chemical reaction is happening, uh, while a chemical reaction is happening, the acidic and the basic nature also changing. This is that reaction. You can see potassium hydroxide has changed. It is hydroxide has produced. It is an alkaline solution. That is why we can see this kind of color change in the universal indicator. Another thing is a precipitate is formed. A precipitate is an insoluble solid. Precipitate means an insoluble solid. The reaction is silver nitrate and calcium chloride. The things producing are silver chloride and calcium nitrate. Here, you can see during this reaction, a precipitate is forming. You can see one solution is somewhat milky and the other one is colorless solution. Then, when we are mixing them together, we can see white color precipitate is forming. Now, the new topic is rusting. Some reactions are not useful. Some chemical reactions are not useful. Then, this rusting is that kind of chemical reaction without any usage. When something has rusted, we cannot use more and more, then it is not a useful thing. Then rust is formed when iron reacts with oxygen in damp condition. Damp condition means a wet condition. Iron is combining with oxygen in that moisture condition and form iron oxide. That is the rusting process. And rust is formed when both oxygen and water are present. To form the rust, it should have both oxygen and water. If there's no water particles or moisture, then the rusting is not happening. If there's no oxygen, but there's water, but without oxygen also, the rusting is not produced. Not rusting is not happening. Now we will see what causes iron to rust. The reason, the things that want the iron to rust. There's an experiment. Test tube 1 contains nothing apart from the nail and is open to the air. You can see there's nothing and it has opened to the air. Test tube 2 contains water and the nail is half in water. The test tube is open to the air, so this tube has water and air. Both are there in the tube 2. Test tube 3 has calcium chloride in the bottom. The calcium chloride absorbs water, so the air inside the tube is dry. In the test tube 3, there's calcium chloride. Calcium chloride can absorb water. So in this test tube, there's no water. And the tube is stopped, so the air also cannot enter to the atmospheric air and the water particles cannot enter to the test tube 3. But inside the test tube, there's oxygen gas. Test tube 4 has water that has been boiled to remove as much dissolved gas as possible. On the top of the boiled water is a layer of oil. You can see there's an oil layer and there's the boiled water. Boiled water did not contain oxygen gas or any other gas, and if there is a oil layer, any other gases cannot enter into this solution. That is why we are putting a oil layer here, and this stops any air entering the water. The tube is stoppered. Stoppered means it has closed. Then the atmospheric water and the air also cannot enter to this. Then after few weeks, the experiment looks like this. And these are the pictures after few weeks. We will see it is from a table. Test tube 1, you can see it contains moist air. So moist and air both are there. So nail has rusted in tube 1. In tube 2, there's water and air both are there. So nail is very rusty. You can see in the picture test tube 2 has all the requirements, so it has rusted more. First one you can see there's air can enter to the test tube and the water vapor also can enter to the test tube. But without water also, the water vapor also can help for the rusting process. So you can see it has rusted. But the nail containing in tube 2 has rusted more than that. And the third one, there's dry air. That means no water particles in that, so no rust in that. In fourth one, there's boiled water, so there's no air. If there's water, there's no air. So you can see, uh, but some amount of air can be seen. Then we can see very small amount of rust because most of the air has released out, so very little amount of rust can be seen. Now we'll see how can iron be protected. First thing we can do is can be paint. We can paint the iron nails by using any kind of paint. Then if we paint it, we can stop the oxygen in the air reaching the iron. Then if there's a paint, the atmospheric oxygen cannot contact with the iron. So the rusting is not happening. And another thing can be galvanized. We can galvanize the iron. Galvanizing means covering the iron with a layer of zinc. Then when we apply zinc on the iron object, then it also prevent the contacting with oxygen. The iron is not contacting with the oxygen gas. That is why it is not rusting. This is the end of today's lesson. Thank you for watching and subscribe the channel to watch more videos like this.